Let's talk about how to calculate the circumference of a circle and the length of an arc. In order to do any of that, we're going to need to use pi. Pi is a lowercase p in Greek, but more importantly, it's the ratio of a circle's circumference to its diameter. So you could say that pi is equal to circumference over diameter, or since diameters are equal to double the length of the radius, you could say that pi is equal to the circumference over 2r. But more often than not, we would prefer to be solving for the circumference, so we can multiply both sides by d, or multiply both sides by 2r, and say that the circumference is equal to pi times the diameter, or that the circumference is equal to 2 pi times the radius. So let's calculate the circumference of this circle. Since we know the diameter, the formula for the circumference that we'll want to use is circumference equals pi d. So I can say that the circumference equals 40 pi, which is approximately 125.7 yards. On our next example, we're given the radius instead of the diameter, so this time I'll want to use this version of the formula, 2 pi r. So the circumference equals 2 pi times 18, or 36 pi, which means the circumference is approximately 113.1 feet. You can also use the circumference to calculate the length of the diameter or the length of the radius. Since this time we're being asked to calculate the length of the diameter, we'll be using circumference equals pi d. So since we're given that the circumference is 55 centimeters, we're going to plug 55 in for c. So I have 55 equals pi d. And I can divide both sides by pi, because remember, pi is just a number. I know that might feel strange to divide by pi, but you're really just dividing by 3.14159, yada, yada, yada. So 55 divided by pi gives me an approximate diameter length of 17.5 centimeters. Let's use the circumference to calculate the length of the radius. Since I'm calculating the radius, I need to use 2 pi r. So I'll plug in my circumference, which is 106, and divide by 2 pi. Now be really careful when you're typing that into the calculator. If you just type in 106 divided by 2 pi, it's going to divide by 2, and then whatever that answer is, it's going to multiply that by pi, and that's not what you want to do. You want to divide by 2 pi. So if you're dividing by 2 pi, please put parentheses around 2 pi to make sure that it's dividing by 2 pi, not dividing by 2, and then multiplying by pi. You should end up with an answer of 16.9 kilometers. Since the circumference is really just the distance around the circle, we can use it to calculate how far a wheel travels. If a wheel rolls 1 revolution, then it traveled the length of its circumference. And I can figure out the length of its circumference using circumference equals pi times the diameter. So each revolution of this wheel is equal to about 56.5 inches. And we can expand that for this little hamster right here. Harold the hamster is running on his hamster wheel. How many revolutions will he have to complete in order to run 1 mile if the diameter of his hamster wheel is 6 inches? Well, first let's find the circumference of his hamster wheel. Since I know the diameter, I'll use c equals pi d, so c equals 6 pi. So the circumference of his little hamster wheel is about 18.8 inches. But we want to know how many revolutions he needs to go in order to complete 1 mile. So I need to know what a mile is in inches. There are 5,280 feet in a mile, and there is 12 inches in a foot. So if I multiply the number of feet in a mile by the number of inches in a foot, I get the number of inches in a mile, which is 63,360 inches. So if I divide that number by the number of inches he covers with 1 revolution, we find out that poor little Harold is going to have to complete 3,370 revolutions in his little hamster wheel in order to have run a mile. What if we don't want to calculate the entire circumference? What if, per se, we wanted to calculate the length of an arc whose degree measure was 180 degrees, and the diameter of that circle was 12 meters? Well, 180 is half of the whole circle, right? 180 divided by 360 is 1/2, or 0.5. So we could just find half of the circumference of this circle and know that that was equal to an arc of a measure of 180 degrees. So 1/2 of pi d gives me an arc length of 18.8 meters. Okay, what if I don't even want a half? What if I want an arc whose degree measure is 90? Well, 90 is a quarter of the circle, 90 divided by 360 is 1/4. So I could take 1/4 of the circumference to find the length of an arc that has a 90-degree angle measurement. Okay, what if I wanted something even smaller? What if I wanted an arc whose degree measure was just 20 degrees? Well, 20 is a 1/18 of an entire circle. 20 divided by 360 is 1/18. So I could take 1/18 of the entire circumference and find out that that teeny tiny little arc length would be 2.1. And basically this process is what you'll do each time to figure out the length of an arc. So this formula looks really scary, but it's really not. Each time you'll be given the length of the radius, so you'll put that in here for the 2 pi r, that's the circumference of the entire circle. And you'll be given the degree measure of the arc, or the central angle. So just like we did for each of these problems that we took the degree measure and divided it by 360, we'll do the same thing each time here. We'll take the degree measure we were given and divide it by 360. That is proportional to the length of the arc over the length of the entire circumference. Let's give it a try. So we need to calculate the length of arc DE. I'll call that x. So the length of the arc over the circumference of the entire circle, which is 2 pi r, and we're told that r is 7 inches. That's equal to, or proportional to, the degree measure of the arc over the degree measure of the entire circle. So arc over whole circle is equal to arc over whole circle. It's just a proportion. So cross multiply and solve, and we find out that x, or the length of arc DE, is approximately 17.5 inches. Let's try another one. Except this time we're not given the degree measure of the arc, we're given the length of the arc. So we'll be plugging numbers into different parts of our formula, but it's still going to be the same process. So the length of the arc over the circumference of the entire circle is equal to the degree measure of the arc, which is what we don't know this time, over the degree measure of the entire circle. So cross multiply and solve, and we find out that the degree measure of that arc is approximately 105.5 degrees. We can even use this formula to calculate circumference if you're not given the radius. This time we're given the degree measure of this arc and the length of that arc, and we can use that to calculate the radius. And once we know the radius, we can calculate the entire circumference. So the length of the arc over 2 pi r, because I don't know what the radius is, I don't know what the circumference is equal to the degree measure of the arc over the degree measure of the entire circle. Cross multiply and solve, and I find out that r is 23.7 yards. But that's not my final answer because I was asked to figure out the circumference, and this is just the radius. So the circumference of a circle is equal to 2 times pi times the radius, so the circumference of this circle is approximately 148.9 yards. On our next example, we're given so much information, and it's really our job to figure out which pieces of information are important in order to figure out the length of arc QU. Well, here's QU. I need to know the radius of this circle, and I need to know the degree measure of that arc in order to figure out the length of the arc. I'll call this arc length x, and I'll put that over 2 pi r. Now, none of these radii are labeled, but I'm told that the diameter is 5 meters. It's labeled outside of the circle, but it's still considered a diameter. But I don't want the diameter, I want the radius. So I'll say that it's 2 pi times 2.5, because half of the diameter is equal to the radius. Or, honestly, you could have also just said it was pi times 5, because the formula for arc length uses 2 pi r as its circumference formula, but pi d is equally as correct, so you could have also just said pi times 5, and that's fine. Equals, well, what's the degree measure of this arc? That's not given to me. But I know that QUT is a semicircle. Semicircles always measure 180 degrees, so if part of this semicircle is 40 degrees, I can figure out the other part by subtracting from 180. So the degree measure of arc QU must be 140 degrees. And I'll put that over the degree measure of the entire circle, which is 360. So cross multiply and solve, and we find out that the length of arc QU is about 6.1 meters. So let's apply this knowledge to a couple of word problems. A wiper blade measures 21 inches long and travels in an arc that measures 135 degrees. So how many inches does the tip of the wiper blade travel? Well, x is going to be what we're solving for. That's the length of the arc. The wiper blade is the radius of this circle. I know that wiper blades don't go all the way around in a circle because then it would go through your engine block and that would not be good. But if it did, you could imagine that the wiper blade was a radius. So I have 2 pi times 21. And we're told that the degree measure of that arc that the wiper blade travels in is 135 degrees, and of course the degree measure of a whole circle is 360. So cross multiply and solve, and we find out that the wiper blade travels approximately 49.5 inches as it travels across your windshield. Next up we have Martha, and she wants to put a flower bed in the corner of her yard in the shape of an arc. The fences in that corner of her yard meet at a 75-degree angle, and she wants the flower bed to come out 4 feet from the fence and have a circular edge. Will 5 feet of edging be enough to go around the curved edge of the flower bed? Well, let's fill in our formula. We're looking for the arc length. That's going to be synonymous with the edging for her flower bed, so we'll call that x. The flower bed is going to come out 4 feet from the corner of the fence and have a circular edge, so in other words, the radius of that circle is 4 feet. So I have 2 pi times 4. The degree measure of the fences is 75 degrees. The degree measure of a whole circle is 360. So let's cross multiply and solve, and we find out that the edge of her flower bed is going to be 5.2 feet. So is her 5 feet of edging enough? Not quite. And that's all you need to know about calculating the circumference of a circle and the length of an arc. In our next video, we're going to discuss how to calculate the area of a circle and the area of a sector of a circle.